Hello, good day. I'm glad to present our work named UVLens, which is Urban Village Boundary Identification and Population Estimation leveraging government open data. My name is Longbiao Chen, Assistant Professor from Xiamen University, together with my collaborators. In this very difficult situation, I hope you are all doing well and take good care. Now let me start the presentation. Here is an image of a typical urban village in Shenzhen, China. Urban villages refer to the residential areas lagging behind the rapid urbanization process in many developing countries. For example, in China, although the urbanization rate is close to 70%, a lot of old cottages remain and scattered in the city. The residents, sometimes called the ant tribe, are usually low-income and transient inhabitants, such as migrant workers in nearby factories and even low-income university graduates. Urban villages provide them with affordable housing conditions close to public transportation at a relatively low price. However, urban villages also bring several social and economic problems for urban authorities. Urban villages are generally overcrowded, filled with illegal apartments and family rentals. The living standards in urban villages are relatively low, and the lack of public health systems make urban villages vulnerable to infectious diseases such as the COVID-19. Therefore, it is essential for urban authorities to note about the basic situations about these areas. The first key question is to know where and how large in the city are the urban villages, or to identify urban village boundaries. And the second question would be knowing how many houses and how many people are living in these areas, or to estimate the population of urban villages. Traditionally, urban authorities usually resort to field surveys and demographic census by sending out investigators to urban villages. However, these methods are usually time-consuming and human-intensive. Besides, as urban villages are continuously being renovated, these statistical data are easily outdated and do not reflect to the state of the art. In this paper, we propose a new idea to identify urban village boundaries and estimate their populations leveraging heterogeneous urban data. Specifically, we resort to the following two categories of urban data. The first category is infrastructure data, including high-resolution remote sensing imagery, citywide street view imagery, and also points of interest. The second category of data are instead collected by ubiquitous devices from large scales of crowds, including taxi GPS trajectories, bike sharing system records, and so on. The proposed framework is shown as follows, including two phases. Now, let me first introduce the first phase, urban village boundary identification. In this phase, our objective is to identify urban village boundaries from remote sensing imageries. Although such kind of image classification and segmentation tasks are not difficult, when directly applying existing algorithms to our work, we face the following two issues. First, if we clip a large remote sensing imagery into fixed-site imagery patches, the resulting urban village boundaries might be incorrect, leaving lots of spaces alongside the grid borders. Second, these algorithms tend to classify similar function areas such as old residential buildings as urban villages. In a word, we need to incorporate more information to achieve better boundary identification results. In this work, we propose to fuse cloud sensing mobility data with remote sensing imageries to improve the boundary identification accuracy. Specifically, in order to avoid incorrect boundaries, we eject road networks from taxi trajectories and generate patches to maintain the integrity of urban villages. And second, in order to avoid identification errors, we fuse the bike sharing use data to distinguish urban villages from residential areas, as bikes are usually not allowed to enter residential areas. Here, we show an illustrative example of urban village boundary identification results. We can see that with the help of bike usage data, we can safely avoid residential areas from being identified as urban villages. And also, by leveraging road network guided patches, we can identify the urban village without missing boundaries. And now let me introduce the second phase, urban village population estimation. We consider the factors impacting urban village population from the following two aspects. The first one is the living space, which can be estimated by counting the number of houses from satellite imagery. The second factor is human activity intensities, which can be estimated from bike usage and POI hotness. Therefore, our basic idea is like if we see a urban village with crowded houses and frequent bike usage, we can infer that there might be more population in this urban village. Specifically, we first extract a household capacity feature in different kinds of houses with different sizes, including residential houses, rental apartments, residential apartments, and old houses. An empirical formula is used to estimate the population basis. We then refine the population estimation with human activity features to reflect the overcrowded situation of urban villages. Specifically, we derive a weekly activity intensity from bike usage and also the commercial hotness of POIs. Finally, we evaluate the performance of our approach using real-world data collected from Xiamen City. We use satellite imageries from Google Earth and taxi and bike trajectories along with POIs in different categories. Here is a glance of the data we used. We now present some interesting findings in our evaluation. The first one is the vanish of an urban village called Dongjai. We can see that since 2015, the urban village was shrinking gradually and its surrounding road network was changing dynamically. We also present two negative cases here. On the left, we show an urban village which is not detected by our method, since it is a small urban village in big patch and which are difficult to detect. On the right, we show an urban village with wrong population estimation. The reason is that the urban village has become one of the tourist attraction, and its human activity are largely affected by tourists instead of reflecting the residential population. Recently, we have also deployed our system on the Xiamen Urban Big Data Security Open Platform to provide information services to urban authorities and the citizens. And finally is our takeaway message. In this work, we present a fine-grained and low-cost approach to urban village identification and population estimation. The proposed framework is a heterogeneous data fusion framework leveraging infrastructure and crowd-sensing data. We perform real-world evaluation and deployment in Xiamen City in China. And this is Dongbiao Chen from Xiamen University. Thank you for your attention.